Hello guys, welcome to our Geometry Full Course series here at Forward Ed. This playlist will include all of our videos for the entire course, and we'll begin here with Chapter 1. We're in Foundations for Geometry in Chapter 1, and our very first set of videos here will be exploring 1.1, understanding points, lines, and planes. So let's zoom over to our lesson. Let's take a look here at our picture. A little challenging to see there from the textbook, but we have this is inside of the National Stadium in Beijing. This was built for the 2008 Olympics. Now, architects who designed the building, they used tiny dots called points, straight paths called lines, and flat surfaces called planes to plan the entire structure. And today we're going to look at and learn what those three words mean in geometry and how to write them down. Now let me zoom out a little bit. We'll go back over to our main page here. In math, some words are so basic that we can't really define them with simpler words, so we call those undefined terms. And in geometry, the three undefined terms are point, line, and plane. So in other words, we don't define them, we just describe them, and we use them as building blocks for everything else in geometry. So we can describe them and draw them. They are the building blocks of all geometry, just like the letters A, B, and C we consider the building blocks of words. All right, let's take a look at our first row in the table. So a point names a location, like a single spot on a map. It has no size, even though we draw a dot to show it. The real point has 0 width and 0 thickness. It's just the location itself. Now we name a point with a single capital letter. So in this diagram, on the right side of the row, we can see a tiny dot labeled with the capital letter P. And we read that as point P. Now what I want you to keep in mind is that the dot we draw is bigger than a real point, because a real point has no size at all. A lot of students struggle with this idea a little later on if it's not made clear, so let me say that right now. Now let's take a look at our second row. A line is a straight path that has no thickness and it goes on forever in both directions. So imagine a perfectly straight road that never ends. That's what a line is like in geometry. Now there are two ways to name a line. The first way is to use a single lowercase letter. Like line, that's the cursive letter L here. I'll circle. And the second way is to pick any 2 points on the line and to name the line by those 2 points. For example, if X and Y are points on the line, then we can call it line XY. And we write it as the letters XY with a small double-headed arrow on top to show it goes both ways. We could also write YX. We could also call it line YX. The order of the two letters does not matter for a line. Let me circle that. XY, YX, same idea. We can rearrange those letters on a line. Let's take a look at our visual. Here we have XY left to right, and right to left would go YX, because they go in infinite directions. We can flip them and name them either way. There's our little cursive L for line. So again, those little arrows tell us that the line keeps going forever in both directions, even though we only drew a small piece of it. Now let's take a look at our third row here. This is all about a plane. A plane is a flat surface that has no thickness and it extends forever in every direction. So think of a perfectly flat sheet of paper that goes on forever in all directions, never curling, never ending. That's a plane. Now we can name a plane in two ways. The first way is to use a script capital letter. That's like that fancy cursive capital letter, like script R. That's how we can write it. we say plane R. The second way is to use any 3 points on the plane that do not lie on the same line. For example, plane ABC. Here's ABC here. ABC. Now, why a parallelogram? It's just an artist's way of showing a flat surface seen at an angle, like the corner of a tabletop. A plane is not actually a parallelogram. It just looks like one here because it goes on forever. Remember that for plane. Excellent. Now that we went over our undefined terms, let's zoom in on our next vocabulary terms. Collinear and coplanar. Now the word co as a prefix in front of something means together, so collinear means together on a line. Points that lie on the same line are called collinear points. Let's take a look at the small diagram here to the right. We have points K, L, and M. They all sit on one horizontal line, so they are collinear. But notice that point N sits below the line. So it's not on the same line as KLM or KL and N. So KL and N are not collinear. We call that non-collinear. Now let's extend that. In the same way, coplanar means together on the same plane. Points that lie on the same flat surface are coplanar, and if they don't, they're non-coplanar. So in other words, 3 or more points are collinear when you can connect them all by drawing one single straight line through every one of them. If you can't, then they are non-collinear. All right, with that being said, let's take a look at our first example. And before we do this example, we can read the helpful hint from the book here on the side. A plane may be named by any 3 collinear points on that plane. So plane ABC could also be called plane BCA, plane CAB, plane CBA, plane ACB, or plane BAC. Any order of those 3 letters names the same plane. And this hint does matter because students oftentimes think that plane ABC and plane BCA are different planes. They're not. They're the same plane named in different order. In a different order. Now let's take a look at our example. Part A here is asking us to name 4 coplanar points. So let's remember that coplanar means on the same flat surface. Here's our photo here to the right. Let's go to white for our color pen. And we're looking at KLMN. KLMN. There they are. Circle those. KLMN. Notice that these all sit on the same flat region of our roof. Now that region is the plane, labeled R here. So we call this plane R. So those 4 points are coplanar. So since K, L, M, N all lie in plane R, we can say K, L, M, and N all lie in plane R for our answer. Okay, let's take a look at part B. Part B here is asking us to name 3 lines. So let's look at the top of the photo. The points A, B, and C form a small triangle. And the 3 sides of that triangle are 3 straight lines that we can name. A, B, C. And here we see that they form a triangle. We can see that triangle lightly here. I'll retrace over here. There's our triangle. All right, so let's consider that the first line goes through A and B. So we call that line AB. Written like this, as the letters AB with a small double-headed arrow on top. Now the second line goes through B and C. So it's line BC. written like this. And the third line goes through C and A. So it's line CA. Here are the 3 lines that we can name and write them with their proper symbol. Line AB, line BC, line CA, and each with a double-headed arrow on top. Now you may be thinking, could we write this as line BA instead of line AB? And yes, absolutely, that's the same line. We can name it either way. All right, let's take a look at the check it out. Use the diagram to name 2 planes. So if we look at the picture here and find 2 flat surfaces, one is the flat region with KLMN, that's plane R, right? And the other can be named by any of the points A, B, C, like plane ABC. So 2 correct possible answers are plane R and plane ABC as such. Now the triangle ABC also lies on a flat surface, so we can name that plane by its 3 points. So our possible answers are plane R and plane ABC. All right, let's continue on. Now we'll take a look here at segments, endpoints, rays, and opposite rays. Let's start off by defining a segment. So a segment or line segment is the part of a line that includes 2 points and all of the points between them. So think of it like this. A line goes on forever in both directions, but a segment is just a piece of a line, a segment. It has a clear beginning and a clear end. Snip, snip. Take it out of the infinite arrows that point in both directions. Snip, snip. And now you have a finite measurement. So those 2 ends are called endpoints, and we name a segment by its 2 endpoints with a small straight bar on top. For example, segment AB or segment BA here. Now the order doesn't matter. Segment AB and segment BA again are the same segment. Segment. And here we are, our segment all the way across, but with definite finite endpoints there for a segment. All right, let's clear that and we'll take a look at our second definition here, endpoint. An endpoint is a point at the very end of a segment or the starting point of a ray. We're going to talk about rays next. We name endpoints with a capital letter like point C or point D. They're simply the dots at the end. And that's it for endpoint. And then let's take a look at ray. A ray is a part of a line that starts at one endpoint and goes forever in only one direction. So a ray has a beginning but no end. And as such, we name a ray by its endpoint first, and then any other point on the ray. And we put a single arrow on top pointing to the right. For example, ray RS. Written as RS with a right pointing arrow on top. It has R as the endpoint and goes through S and beyond. So the endpoint must be named first. The order does matter for rays. Let's take a look at that in our diagram. Here's our endpoint. R, that's our solid dot. And then we can trace the arrow going from R through S to the right. Here's the endpoint again here. Going to the left, the endpoint does matter. Now for a line, we use a double-headed arrow, which goes both ways. For a ray, we use a single arrow pointing to the right. It goes one way only. For a segment, we just use a bar, no arrow. It doesn't extend. It's a segment. All right, there's that, and now we're ready for opposite rays. Now, opposite rays are 2 rays that share the same endpoint, and together they form a complete line. So they go in exactly opposite directions from the same point. So if we take a look at our diagram here, point E is in the middle. One ray EF, starts at E. That's the common endpoint. And it goes left through F. And the other ray, EG, starts at E and goes right through G. So together they form one straight line. Now, some common student mistakes include that rays EF and FE are not the same. The first letter is always the endpoint. EF starts at E, FE starts at F. So let's make sure we remember our ray begins with our endpoint and moves left or right. All right, we'll go ahead and stop our first part here. And in our next part, we'll be drawing segments and rays. So be sure to tune back in for part 2. We are in 1.1, the very first section of chapter 1, where we're understanding points, lines, and planes. See you soon.